Welcome to the Stormsurf video surf forecast for the week starting Sunday, August 24th. Brought to you by Vunabaka.com, a new surf and water-based residential community in the island of Fiji. First up, we'll take a look at significant wave heights for the North Pacific Ocean. Obvious on the chart, Super Hurricane Marie, south of Cabo San Lucas, 140 knot winds, that's 161 miles an hour, and barely in the Southern California swell window. Large swell is expected to be radiating into the Southern California area. Also, remnants of Carina and Lowell hanging off the coast. A little bit of energy moving towards the Hawaiian Islands. Certainly swell has hit Southern California, and for that matter, Northern California over the past weekend, but is starting to fade and will continue to dissipate by Monday. Otherwise, not a whole lot going on. Let's put it into motion. Just click through here. Watch Marie pulling more into the swell window, but also taking a more westerly track, and winds settling down somewhat as we move into the work week. Notice a low pressure area trying to get going off of Kamchatka by Wednesday, not making a whole lot of progress, but notice this and the one before it actually survive and make it across the journey here. A good sign for the fall to come. Anyway, Marie fades out by Saturday. A rather placid pattern sets in, and so once again we're forced to start looking to the south for swell. And looking to the south, significant wave height charts, we see a small area, 26-foot seas. These are actually pushing to the east, part of a small gale that previously was off New Zealand, just tiny in size, got maybe 26, 28-foot seas, sort of pushing towards Tahiti and a little bit towards Hawaii, but then quickly sort of turned off to the east. Not a whole lot is expected from that. But the charts hold promise, if you believe them, for the long term. Let's start digging into the detail. First up, we'll take a look at jet stream level winds. These winds help support the formation of storms and also help determine their track when they do form. What we're looking for is troughs, that is, strong winds pushing north, forming kind of a bow in the jet stream. That helps promote circulation down at the ocean's surface, or at least in the mid-levels of the atmosphere. That creates low pressure and creates winds and creates swell. Okay, right now, not a whole lot of winds, but the pattern is sort of supporting high pressure over New Zealand, which is good, and then a northward flow, and here we have a trough south of Tahiti. This is kind of a good configuration if we could get more wind pushing up into it. So right now, not a whole lot going on, and a big ridge pushing south here off of South America, not doing anything for swell production. It actually would push the storm track into Antarctica. Let's put this into motion, see what happens. We sort of pull this out. As we get into Tuesday, we have 150 knot winds starting to develop a new little trough building here. Let's see if it gets any northward push to it. Not a whole lot, but then looking good. By the time you hit Thursday, Friday, we have 160 knot winds pushing well to the north. A good trough starting to dig out here, supportive of gale development. And look at that. You get winds up to almost 180 knots on Friday. This is interesting. The models have been hitting at this, then it backs off. Then a couple runs later, it comes back. If this were to happen, this would provide great support for storm development down in lower levels of the atmosphere. The interesting part is that this is the 18Z run of the model. We were looking at the 12Z. It had none of this here. Now we're at the 18Z run. All of a sudden, it's woken up again. This would suggest that, in fact, a real summer pattern is finally starting to form in the end of August. Anyway, look at this trough. Beautiful trough into Saturday night and continues on into the end of the model run Sunday night. So, if one is to believe in the models, there's good support, at least in the upper levels of the atmosphere. Next, we take a look down at the surface. Surface level winds, surface level pressure. It is winds interacting with the ocean on the ocean surface that create raw seas. Those seas, as they radiate away from the storms, turn into swell. Swell, when it impacts the coast, creates surf. As of right now, a broad gale, but rather disorganized pattern. Part of that low we were looking at earlier, all the fetch here is really aimed almost southeast. A little bit 30-knot fetch, sort of pushing up towards Tahiti, but you need much stronger winds than that to make about a 16-second period swell. That's what it takes to survive the journey to make it to Hawaii, U.S. West Coast, and Central America, of course. Tahiti, much closer, takes much less energy. So this is all good for 14, 15-second period swell, maybe. Anyway, roll this out. Notice some sort of stormy patterns continues, and then here we go. We're into Monday night, 45-knot winds developing southeast of New Zealand. Continue aiming well to the north, covering a pretty decent area. That one fades out, but here you go into Wednesday. A much stronger, broader area, 45-knot winds builds, 50-knot winds by Wednesday night, and even a small pocket of 55-knot winds. This is good for much longer period swell production and legitimate seas that could make a swell of interest if it were to happen. Secondary fetch develops Thursday night. Again, a small pocket of 45-knot winds, and yet more behind that. So just a sort of continuous production of fetch here into, geez, almost out the end run of the model. So this is what you'd call a complex gale. Large area, covers here, and just pulses of energy continue to, it sort of self-generates pulses. If this were to happen, this would be great. This is making a really good long run of swell energy for all the targets from Chile on up into Central America and North America, Hawaii, the whole bit. Great positioning. We'll believe it when it happens. Let's go take a look at the wave models. So here we go, South Pacific significant wave height chart. We can do some things with this one, so we'll use this version of the chart. We're kind of sitting here waiting. Of course, there's Marie. We talked about that up north. And then finally, Monday night, Tuesday morning, little gale starts forming, 30-foot seas. Doesn't do a whole lot, more like a primer, just sort of roughs up the ocean surface, kind of gets things going. And so if it stays that, if it gets roughed up, then you have another fetch come in there. The secondary fetch, or the second fetch, doesn't have to like start from zero. There's already there's something for the wind to grab onto, and it can ramp up sea production much quicker. And sure enough, it does that. By Wednesday night, we're talking 38-foot seas. If that were to happen, that would be a great thing. Relative to Northern California, that looks like about, hard to see here, about 203-degree path, just barely, about 205, still in the Tahitian swell shadow, but then, 40-foot seas pulling quickly out of the Tahitian swell shadow, good relative to Northern California. Hawaii, we'll roll this back, kind of just barely there, sideband energy, and Southern California is pretty much the same as Northern California, give or take about 2 degrees, so same deal going on there. Roll this forward. That one moves off and still continues to produce pockets of 30, 32-foot seas. It was up to 40 feet at one point there. And then here comes another pocket, and we're out 180 hours. So that's most promising if it were to happen. So we roll this back. Here's the peak of it, 12Z on Thursday. And that was actually not in the swell shadow. That's about 42 feet, 41 feet, 202 degrees relative to Southern California. What is that? About 200 degrees relative to North California, and Hawaii just about out of the window, about 180, 179 degrees. So that would be pretty good if that were to happen. Something to look forward to at least. As you know, we've been following the potential development of El Nino, so let's go into taking a look long-term how that is going. Of course, if El Nino were to form, that would have a positive impact on our fall and winter surf season in the North Pacific. At this point in time, it's pretty much looking like we're in for some form of El Nino. Southern Oscillation Index, difference in pressure between Darwin, Australia, and Tahiti, minus 11.59. That's good. Notice a pretty good run of negative numbers here. At a minimum, that's suggesting the active phase of the MJO is happening. The 30-day running average is now down to 9.34, again suggestive of the active phase of the MJO. The 90-day average is down to 3.33. Not far enough yet to suggest anything El Nino-wise, but definitely getting out of the neutral or even weekly positive range. Something, and given the time in the season, this would be about right for this to start continuing to fall negative. Looking at the trend, 30-day Southern Oscillation Index, we're now down almost at 10. The only time we've been that low in the past couple of years is, of course, the big run we had in January through about April, where we generated massive Kelvin wave, massive westerly wind bursts, and then a brief little interval in that range in July of 2012, when again we thought we had El Nino developing, but it was a false start and it quickly dissipated. So we're heading in the right direction. Things are looking good. Two big negative dips here in about a 6-month time frame. That is positive. Next, we take a look at surface level wind anomalies. These are wind differences from normal for this time of year. What we want to see is westerly anomalies, and we want to see it in the region bound by a box by a couple of degrees either side of the equator, going here from about 140 to about 170. This is what we call the Kelvin wave generation area. Currently, we're seeing pretty much a neutral pattern. That is, not westerly, not easterly, just something in between, kind of normal for the time of year. This is up at the 850 millibar level, 4,500 feet up. Sometimes, which is supposed to be a good representation of what's happening at the surface. But as we've seen, the surface buoys in this area sometimes tell us a different story. So we'll get into that in a minute. So anyway, here's Australia, West Pacific dateline, pretty much neutral pattern there. As we go east, light westerly anomalies, a little bit stronger here in the intertropical convergence zone. Certainly that's feeding tropical development. Marie there, and the remnants of Carina and Lowell also hanging there. A lot of the tropical development being driven by westerly anomalies. Next, we go out 180 hours, a weak easterly anomaly pattern suggested here north of Australia, going pretty much neutral, and then starting to come a little bit west here around the dateline as we approach Hawaii. But nothing really strong. Pretty much just a neutral pattern is suggested per these charts for the next week. Next, we take a look at outgoing long-wave radiation forecasts. These are somewhat similar to the east-westerly anomaly charts we looked at, in that the yellows, oranges suggest a lot of reflectivity off the ocean surface. That suggests the inactive phase of the MJO and perhaps easterly anomalies. So the statistical model here definitely suggests some sort of inactive phase apparently in play, even though the SOI numbers suggest otherwise. So we have contrary data here, and the model suggests, though, by about 8 days out or so, that whole thing's supposed to fall apart. The dynamic model is a little bit more bullish, suggesting that the inactive phase is supposed to hang on. It's going to be interesting to see what really happened. And the upper level, this is a 40-day model. We've had lots of problems with this. Hard to believe what it tells us, but it's sort of consistent with the previous models we saw, in that the inactive phase is in control, in the upper level of the atmosphere, pushing east, supposed to work its way across the Pacific through about the middle of September, and then the active phase starts building, working its way across. It's the active phase that we would expect to produce westerly winds and actually help support some tropical development in the West Pacific. And that's really what we're looking for, is a somewhat active, weak active phase of the MJO, supportive of tropical development, so that tropical systems off the Philippines curve north off Japan and then make a curve to the northeast and east, and then develop as they cross over the dateline. And that typically what help promotes storm and surf development in the early part of the fall. And in fact, the large El Nino year of 97-98 started out with an extratropical storm crossing the dateline, 50-foot seas, which created swell of 10 feet at 20-plus seconds into Northern California late in September. We do not expect that to happen this year, but that is sort of the baseline for all-time great early season strong period swells. Next, we take a look at surface level water temperature anomalies. If El Nino were in play, you would see warm water in this region forming sort of a triangle going off like that. In fact, we do see that. Not particularly well defined, a little bit ragged, but still hanging in there pretty well. And supposedly, we are in the upwelling phase of the Kelvin wave. That is, there's a big pocket of warm water created by westerly winds here in the early part of the year. It impacted the Galapagos, which is exactly what it does. It basically goes under the ocean surface on the equator, but under the equator, and then gurgles up here off the Galapagos and starts building warm water in this area. And what we're seeing is, and then after a big Kelvin wave hits, you typically will see a sort of a pocket of cool water. You get actually easterly anomalies. You get a pocket of cool water that'll gurgle up, and then the whole cycle will start again. So we're in the tail end of the upwelling phase of the big Kelvin wave. But what we've noticed here is that warm water is really starting to build pretty nicely back in along this area. There's still these little pockets of cooler water, but they're not nearly as strong as they were earlier. And if anything, things are starting to look a little bit better. And this has been in place now. This pocket developed in the late May time frame, and so it's been 3+ months. We're into May, June, July, August. We're into 4 months now. That is, as this warm water has staying power, it starts importing energy to the atmosphere. It starts changing the jet stream configuration, and that's how, in fact, El Nino manifests itself. Notice also massive amounts of warm water here over the entire North Pacific. So it's all primed here. Also warm water building here. We suspect another Kelvin wave is in fact in play in this area. The only sort of bugaboo in the whole thing is this little bit of cool water here off of South America. But again, it doesn't seem to be doing anything particularly bad. It doesn't seem to be impacting the development here. Every now and then the tail of it will pop up in this area here and sort of impact the warm water here. The Nino 3.4 region is bound right in about here. This is, if you have warm waters here, that's where it really seems to have an impact on the atmosphere. At this point in time, all our warm water's been in the Nino 1.2 region, right in about here. We're expecting the warm waters to start building and filling in this area in the next couple of weeks as the upwelling phase of the Kelvin wave dissipates and we move into the next phase of the cycle in the fall. High-res surface temperature anomalies can show a pretty decent batch of like 2.5, 3.5 degree waters. I mean, not a lot of expanse, but a nice little core here right on the equator, and bits and pockets scattered around elsewhere out towards the Galapagos. And then further out between about 160 and 100 degrees west, pockets of warmer anomalies, one little pocket of cool anomalies. This just showed up. I mean, on this high-res data, stuff happens. This in fact could be almost tropical related. Things appear and disappear so quickly. It's kind of, you don't want to drill in too much at a single day particular image and get too wrapped up, and it's sort of the general pattern is what you're looking at. And definitely it's warm. It certainly isn't cold. There's no like strong easterly winds blowing here. There's no massive pocket of cool water suggestive of La Nina. So we're definitely in the right mode. We just need a little push over the edge to get us into what would be called a real El Nino. And here's another surface view. Here's actual temperatures, actual winds. Here's anomalies. Notice we have this pocket here. There's 0 degree anomalies there at, what is that, about 120. But everything else is, you know, a half a degree or more in this area. And then this one, here's the, so I would call it the upwelling phase of the Kelvin wave area. This is probably the, you know, the worst of it, which isn't too bad. Wind anomalies here are almost slightly westerly, but that's a bit of a reach, pretty much neutral. So that's the situation there. The subsurface anomalies is where things get more interesting. So this is actual water temperatures. Here's the date line here. The Galapagos are over here. And this is about the western edge of the Kelvin wave generation area, and this is depth. So we're sort of looking at a slice through the ocean. Actual temperatures, here's anomalies. Notice this pocket here. This is pretty much the date line is right here, string of buoys here, and this other line here is 155 degrees. So there's 180, 155. No buoys operational right here. NOAA's trying to go out here and get some of these other buoys operational, but there's funding issues, et cetera, et cetera. But there's been suggestion by other models. This suggests almost 2 degrees here, but it's a model data. So let's go first. Notice there's no cool water anywhere here in the pipe. Warm water the whole way across at depth. This is good because this is the highway that the Kelvin waves take. Down here, generate here, sort of fester, build, and then work their way east, gurgle up off the Galapagos. There's been suggestions that in this region, water temperatures 2, 3, I've seen some models up to 4. In fact, here you go. Here's one that suggests 3-degree anomalies as of the 16th. And notice the highway is pretty much open other than the last little gurgle here of cooler water from the upwelling phase. So this is looking much better than even 2 weeks ago. So we're definitely back in the ballpark. Whether it's 3 degrees, whether it's 4 degrees, whether it's 2 degrees, nobody really knows. There's no sensors. It's all modeled data. So you have to take it on faith that something's happening. This is probably the worst case scenario here in the 2-degree range. And you know what? That's not bad. That'll make it over here in about 2.5 months. That'll add more warming. If trades die and continue light in the in the Nino 3.4 region, that'll promote surface warming and sort of suggest that we're on our way to something that could be considered marginally warm. And yet, one more piece of evidence. As of August 16th, JSON2 data, this is surface height anomalies from normal. Positive anomalies suggest warm water building at depth. We certainly see that here. 5-centimeter anomalies, maybe pushing up to 10. But probably not, just in the 5, which is good for probably, roughly guessing 2 to 3 degrees, something like that. Notice pretty much neutral out in here, but the expectation is that this will make it over this way in time. And finally, upper ocean heat content anomalies, and this is a great chart. So September 2013, first Kelvin wave. Oh yeah, and here's the scale. The west end of the Kelvin wave generation area. The Galapagos Islands would be here, and we're going down time down this axis. So you see a pulse of warm water in the September timeframe of last year. The first little hints that El Nino might be doing something. In October, a stronger pulse, and this is, what is that? 1, 2, 3. That's about 1 to 1.5 degree anomalies. And notice in between these, little upwelling phase, cooler pocket, another cooler pocket. Then the massive Kelvin wave, January, February, March, April. Look at that. We're into, 2.5+ degree anomalies. We think it was 4, actually, somewhere in there. It's sort of hard to tell. Anyway, that impacted the coast. Here's the upwelling phase of the Kelvin wave. Here's the next Kelvin wave starting to form. Sort of weak to moderate, but with time we expect that to get a little bit more momentum behind it. So clearly we're in a good pattern. If this were La Nina, any flavor of La Nina going on, you would see no Kelvin waves. Put a big X right through this. All you'd see is cold water or cool water at depth. You can go look back in some of the historical charts and see La Nina time frames. Not even a hint of a Kelvin wave. They don't happen at all. So by the simple virtues, 1, 2, 3, 4 in about a year time period, that's clearly suggestive that something's going on. The atmosphere is biased and trying to get El Nino going, trying to basically vent off excess heat that's built up in the atmosphere and in the oceans, and that's what El Nino is all about. Just like a hurricane, a way to blow off heat and steam. And so it appears to be that we're out of the regime that we have been in for the past 3 years, where it's just cold and not a lot going on. The other interesting little symptom that we've seen is the big high pressure system that normally sits off of California this summer it's been there, but it's been displaced. There hasn't been a lot of northwest wind. There has been no upwelling. What in fact is happening is there's been eddy flow, south winds, No cold water. Water temperatures have actually warmed. They're 63 degrees in the San Francisco area, and they're in the low 70s in Southern California. Quite warm, quite nice. So all that is sort of another symptom. It is not El Nino per se, but the suppression of the Northeast Pacific high is somewhat indicative that something's going on in the atmosphere that favors El Nino development. And of course, the massive Kelvin waves, you can't ignore that. I mean, that's, so the whole Pacific Basin is biased right now towards something that smells of El Nino. What we really need is more warming in the off of the Galapagos. That will affect the jet stream in time, and as the jet stream configuration changes over the entire globe, that's what sets up El Nino. The interesting part is we've seen some pretty good activity in the jet at times here in August over the North Pacific already. So there are some signs that it's trying to get reorganized as well. And finally, the forecast for the Nino 3.4 region. Water temperatures about 0.75 degrees by early October. This actually dropped down. It's been hanging up around 1. It looks like it's getting more realistic now. And then peaking in about the 1.1 degrees or so in January. The 09-010 El Nino was 1.4 degrees or 1.4 degrees. So this is looking to be a weaker version of that El Nino per this model. And other models have, variations, and even this model you see, depending on when they run it and all that, you get a bit of fluctuation. But that's the average as of right now. And that seems fairly realistic given where we're at, unless this next Kelvin wave somehow really gets some legs under it and really does a lot more than what it appears to be doing right now. So a slow, steady push towards a warmer regime. The reality is, if we didn't get El Nino at all, if we just had like half-degree anomalies or 3/4 of a degree anomaly, which would probably be a minimal El Nino, swell-wise, it would be good, especially if it could linger on for a year or two. That would really set the atmosphere and get some momentum behind it and have a multi-year event rather than this big splurge. And let's say if it was like a 1.8 or a 2-degree anomaly, and then you just fall right back into La Nina. Rain-wise for California, not sure how much, if you only have a half or 3/4 of a degree anomaly, how much that's going to do to support rainfall. But at this point in time, things are looking to be going in the right direction. So for the immediate future, Southern Hemi swell is on the charts. Maybe summer will finally be occurring. Certainly, Super Hurricane Marie is looking good, at least for Southern California, with potentially a decent-sized swell with a decent period working its way into the coast. Probably not so for Northern California because it'll be way too southeast of an angle. And then, of course, the Southern Hemi swells we were looking at, and then of course the El Nino situation going in the right direction. So at this point in time, things are all starting to come together, moving in the right direction, looking good for the next week or two in terms of surf, and longer, hopefully, for the fall. And of course, we'd like to thank our sponsor, Vunabaka.com. Go check them out, Vunabaka.com. The project in Fiji is moving forward. And so that's it for this week. We'll do this again next week, same time, same channel. In the meantime, go get some surf. It looks like there is something to ride. Thanks. Bye.